Hello everyone, welcome to my channel. This is a channel dedicated toward education and upliftment, and hopefully we will be reviewing various theories of everything, all-encompassing theories, cosmologies, magnum opuses from authors and researchers who spent their whole life working on something and probably never really got too much credit or recognition or money. And but I feel like they have something important to say that can really contribute to your overall worldview. And today is video number 336 that we've done on Dewey B. Larson and his reciprocal system of theory. Mr. Larson was an engineer that lived in the 20th century. He died back in 1990, but before that he put in about 60 years worth of work on downloading and then inducing and deducing his reciprocal system of theory. About halfway through that period, around 1959, he put out his two fundamental postulates. And then from there, he derived, through a process of deduction, a theoretical universe about how the universe would operate if his postulates were correct. And then he, in his books, compared his theoretical universe, sized up, his theoretical universe as opposed to the legacy scientists, the Newtonians and the Einsteinians and the quantum mechanists and others, and how, how they were all able to come up with answers to questions. And in the vast majority of cases, the reciprocal system came up with identical answers to legacy science, with the addition that the reciprocal system generally pointed at the relevant concepts that underlie the mathematics and the solution, so-called. Whereas the legacy science often didn't. They had the mathematical answers, but they didn't have the reason why these things are as they are. And then within the relativistic areas, the areas that of the very fast, the very small, and the very large, Larson's theories diverged from the kind of the mainstream, and especially the Newtonian universe, but also to a certain extent the Einsteinian universe. And so not only were the concepts different, but in many cases the math was also different. But the general idea behind the reciprocal system is that we live in a universe not made out of matter and not made out of energy, but and not made out of force, but made out of motion. And motion for Larson was the relationship between space and time. Motion had a fundamental nature that was what he called scalar motion, which is a kind of motion that the legacy scientists knew about, but they didn't understand that it had any significance. They kind of recognized that it was a different motion in kind, an entirely different kind of motion, but they didn't really recognize its significance. And a scalar motion is a motion that has no specific direction. It just has a magnitude. It's a scaling factor. And so um, things move in scale. And so the further out they go, the further away they go in scale, in proportion. And a way to envision that is using a balloon with dots on it. You blow up the balloon, all of the dots are moving away from each other. The farther away they are, the faster they're moving away from each other. But they're not moving in any specific direction. The only thing that gives them direction is when you identify a reference point. If you decide that one of those points, one of those dots on the balloon is motionless, then you can see that each one of the other dots is moving away from that motionless reference point, and you can assign a direction to the direction that it is moving away. So the direction itself is not a product of the motion; it's a product of a reference, of assigning a reference point, a reference system. And so the scientists, they know about the expanding balloon for one reason, that the Hubble telescope has identified that all of the distant galaxies are moving away from each other. So unless we're willing to accept the idea that our galaxy is at the center of the universe, then our galaxy is also moving away from all other galaxies. And that is a scalar motion. But nobody has really identified the significance of that until Larson, as far as I know. And so Larson calls that clock time and clock space. The clock space, all of the space is increasing. All of the dots and all the galaxies are moving away from each other, but in no specific direction. There's more and more and more space. They're moving farther and farther and farther apart. And clock time, which we're more familiar with, is just that time is always getting later and later and later, but in no specific direction. The time is just getting later, and that is, how you kind of look at a clock. It doesn't move in any direction, just forward. And that's the scalar motion to the extent that you could say forward, backward, in, or out. You can say that it does have a direction, but it doesn't have a specific direction like north or south or something like that. Now, also in addition to this scalar motion, we have basically a coordinate reference frame. And so space and time, the two components of motion, and two things that actually don't exist other than when they are together in motion. They don't exist in and of themselves. And they have a reciprocal relationship in motion. As one gets greater, the other gets smaller. They basically are, can be thought of as motion can be thought of as a fraction, with space or time as the numerator and time or space as the denominator. And they both space and time have their coordinate aspects, x, y, z coordinates in space, 3 dimensions. So this is a concept that we're very familiar with. But this same concept also extends to time. There's 3-dimensional time under certain circumstances. And that is something that we would have to, adjust our minds to. But so space and time have their coordinate aspects, they have their clock aspects, and they also have their discrete unit aspects, meaning that they come only in discrete units. You have to have a certain minimum amount of space before you have space, and you have to have a certain minimum amount of time before you have time. And you have to have, if you have 1 unit of space in 1 unit of time, you're talking about the speed of light. And so that is really the 1/1. Larson calls it unit speed. And that's really the background of the reciprocal system or the reciprocal universe. It's 1 instead of 0. The numbers multiply to 1. So you think of the speed of light moving outward in all directions as the reference point, or the 0 point, the null point, the origin, the ether of the reciprocal universe. And that there is actually half of our universe that is moving faster than the speed of light. And so this is an entire kind of new universe to the legacy scientists, who believe that the speed of light is the maximum speed of the universe. And so there is nothing moving faster than the speed of light. Larson identifies this as the cosmic sector, and he identifies entities within this cosmic sector as cosmic atoms, cosmic particles, cosmic molecules, cosmic aggregates of matter. And under certain circumstances, we can observe these things. And in Larson's cosmic sector, we have the ideas of coordinate time, 3 dimensions of time, and clock space. Space is always getting farther and farther and farther apart, because it is the reciprocal of the material sector. The material sector is the sector that we're familiar with, the sector that the scientists, legacy scientists, have made their measurements and their observations. And what we have in the material sector is we have coordinate space, 3 dimensions of space, and we have clock time. The time is always getting later and later and later. But when we cross that unit speed boundary, the speed of light boundary, the rules invert. Typical of a reciprocal. And the rules invert, and then we're dealing with coordinate time and clock space. So that's kind of briefly how the reciprocal system works. And again, he took those, that's the first postulate. The second postulate is basically that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. And some of Larson's followers have had issues with that second postulate, but in any case, it is much less significant than the first postulate. And Larson took those 2 postulates, and then through a process of deduction, he deduced a theoretical universe. It was about 165 steps. And if you go back about 8 or 9 months, maybe even 10 months, you will be able to see me do about 15 videos that's based on Larson's talk called The Outline of the Deductive Development of the Reciprocal System. So I go into full detail about how he derives each aspect of the reciprocal universe. Now today we're looking at installment E, or the 5th installment of us going through Larson's paper that's called The Mechanism of the Universe. This is a paper that's primarily on cosmology, the kind of the macro astronomical universe. What is the origin of this universe? Is it a big bang? Is it going to be a big crunch? Is it an oscillating universe? Is it a steady state universe? And he looks at some of those theories, and then he also proposes what the theoretical universe of the reciprocal system would say that how the universe operates. So if you want to start this at the beginning, you want to go back about 4 videos and start with section A. But this is section E, and we're going to start it right now. Okay, at this point, I must report rather regretfully that the reciprocal system of theory is a great disappointment to the devotees of science fiction. Many of them are full of anticipation when they first hear that the theory involves motion in time. But their hopes are dashed when they find that time travel in a universe of motion is subject to exactly the same kind of limitations as space travel. If we have sufficient time at our disposal, we can always return to a specific location in space by means of space travel, but we cannot return to the same place at the same time. We can only get there at some later time. Similarly, by means of travel in time, it would be possible, in principle, to return to any time location, but we cannot return to the same time at the same place. We can only reach that time location at a distant place. We likewise have to say no to anti-gravity devices. Superman will have to stay in the comic sections. Gravitation is a motion, and the only anti-gravity device is an opposing motion. Larson, for some reason, kind of omits the fact that the progression of the natural reference system, the motion outward at the speed of light in all directions, that is really the ether or the origin or the 0 point of the universe, the always existing before anything else exists, which he calls the progression of the natural reference system, that is an anti-gravity motion. It is a motion that opposes gravitation. You can envision gravitation as just that same balloon with dots on it, but this time you suck in the balloon and all of the dots are moving toward each other. That's gravitation modeled. And so it is the opposite of the progression. So the progression itself is anti-gravity. And if there's any way of harnessing that progression, then you would have an anti-gravity device. But Larson doesn't seem to think that is a possibility. Some of Larson's followers do believe that is a possibility. Okay, so gravitation is a motion, and the only anti-gravity device is an opposing motion. Now, I will have to deepen the gloom by consigning the antimatter energy generators to the same discard pile. There are aggregates of antimatter, or cosmic matter as we prefer to call it, to be sure. There are antimatter stars, clusters, and galaxies, but these are aggregates in time, not in space. And we meet them only one atom at a time. To make matters worse, we will also have to discard what we may call the sanctified science fiction, the many products of the imagination ranging from the fanciful to the fantastic that have been injected into conventional physical and astronomical theory by investigators and theorists who have been frustrated in their attempts to solve their problems in an orderly scientific manner. Such ad hoc concepts as black holes, quarks, the Big Bang, curved space, etc., are no more scientific than anti-gravity devices. They have no place in the new system. In fact, this system outlaws ad hoc assumptions altogether. Returning to cosmology, we now have the answer to the question as to the fate of the galactic fragments thrown off at speeds greater than the speed of light by the explosion of the galaxy. These fragments are observable for a time until the effect of gravitation is overcome, after which they enter the cosmic sector, the region of speeds above unity, and the matter of which they are composed then becomes available for the building of cosmic galaxies. These galaxies recede from each other. They and their constituents age, just as the material galaxies and the constituents do. And eventually, the oldest cosmic galaxies explode and eject fragments at speeds less than unity. The fragments enter the material sector and become available as the raw material from which new galaxies are formed. Now, I must say, I'm not quite understanding why cosmic galaxies, where does it say? Cosmic galaxies recede from each other. They and their constituents age, just as material galaxies do. Now, I would think that if material galaxies are aging, meaning that they're getting later and later and later in time, or older and older and older in time, that cosmic galaxies would get farther and farther and farther apart in space, not in time. I don't know, is there a disconnect there? I'm not sure that I'm understanding why cosmic galaxies would age in time as opposed to moving apart in space. So anybody out there who wants to fill me in on that, what I'm missing there, would be nice, I guess. I have to read the comments a little bit more than I do, though. So I'm sorry that I only seem to get around to reading the comments about once a month or something. And as I probably said in the past here, my budget for this video series is 0, and my spare time for this video series is also maxed out. So please bear with me. I'm kind of just doing the best I can with basically no resources and very, very little time to work on this. So all I can say is I'm doing the best I can. I'm also not an expert on this topic. I'm trying, but it's a very hard subject matter, and I'm trying to present it in a way that you can. I'm trying to present it in a way that you can get it from the primary sources. I'm doing a lot of reading from Mr. Larson and some of Mr. Larson's followers, so that you can get it directly from them, as opposed to me always just interpreting it, because I'm not an expert of it. I can give you a summary of some of these things, but for you to really learn it, I think you need to hear it from the horse's mouth. So I do a lot of reading of various articles and books from Mr. Larson and others. Okay, this then is the answer for which cosmology has been looking. As the proponents of the steady state theory have contended, the universe had no beginning and it will have no end. It has always existed in essentially the same form, and it has essentially the same appearance from any point in space or any point in time. But there is no continuous creation, nor do the galaxies simply disappear over the time horizon, as the steady state theory, as in the steady state theory. In a universe of motion, the large-scale action of the universe is a cyclic process. Each half of the universe, the material and the cosmic, goes through an evolutionary sequence that begins with the entrance of matter from the inverse sector and transforms this matter into compatible structures, gathers it into aggregates, separates the aggregates, and finally subjects them to phenomena that result in the ejection of matter back into the inverse sector. A similar process in that sector completes the cycle. So the universe is cyclical. Each sector has an evolutionary, a one-directional evolutionary motion, but when kind of when the matter in that sector gets to the end of the road, it goes into the other sector and becomes, at the beginning of the road of that sector. And then it evolves and gets to the end of the road in that sector and moves across into the other sector as the beginning of the road. So that's kind of how it is cyclical. Two one-way motions. Okay. Let's do one more paragraph here. For the benefit of those who may be reluctant to accept the idea of a universe without beginning or end, because of a conflict with the religious ideas of an act of creation, I will say that our findings do not affect, repeat, do not affect the creation issue one way or the other. If the universe of motion came into being through an act of creation, then space and time were the entities that were created. There could be nothing before time existed, and if it came into existence as a result of an act of creation, the universe that was created could just as well be cyclic as open-ended. Okay, we're going to stop it right there, and we will start up tomorrow. Hopefully, I guess we have probably an outside chance of finishing tomorrow, and if not, then the day after, with this article, The Mechanism of the Universe by Dewey B. Larson. Thanks for tuning in, and have a wonderful day.